All, this is Dr. Mobeen Sayed from DrBeen.com. Welcome to one more show. I hope you had a great weekend. So, the discussion today I wanted to do was the UK COVID stats. However, Dr. Tommy Zaharakis, who has appeared here as my guest, he sent in a study, it's a preprint, about the hybrid immunity versus vaccine only immunity. Small study, total 22 patients, but very insightful study. And I have been talking about this for about 2 years, that wherever the infection occurs, the local tissue remembers and stays prepared for longer. What that means is, and my apologies, my cat is here as well. What that means is, this is Kyrie. You would see her tail going, here she is. This is Kyrie. So what that means is that if I have an infection on the respiratory system, then my respiratory epithelium and the respiratory surfaces and the cells of immune system near these surfaces will remember that infection and will be prepared for it. On the other hand, if a vaccine is given, for example, intramuscular vaccine, then our body, especially the surfaces of the body, that is epithelium of the respiratory system, will not be as prepared as we will have the antibodies in our circulation. But think about it, for a respiratory virus, it's not necessary to have very high levels of antibodies in the circulation if the respiratory surfaces are better protected. So that's a very interesting study. I had been talking about this concept, immunology concept, for a long time. Here is a study as well. So I am digressing from UK stats, and I'm going to show you this study. If we have time, then we'll go to UK stats, or we'll do UK stats maybe another time, maybe with our own Paul Burke. So let's start. This is the preprint. It says long-term respiratory mucosal immune memory to SARS-CoV-2 after infection and vaccination. In here, when you read this PDF, they have divided the two groups. One they called infection vaccinated, or vaccinated and infected, and the other one they called vaccine naive. Interestingly, they didn't have infection only. That would have been interesting as well. And the reason they said why this study is small is because they did the analysis using bronchoalveolar lavage. That means they actually they send fluids in the lungs, and then they collect those fluids back. So not a lot of people are interested in having bronchoalveolar lavages. Because of that, they didn't have a lot of people participating in the study. But the study results are really interesting. So if I tell you the summary of this, I think you can probably already think about it. The summary is that folks who had vaccine and whose respiratory system was exposed to infection as well, their respiratory system was better able to handle, better prepared to handle SARS-CoV-2, plus was prepared to handle SARS-CoV-2 for a longer period of time, 11 months, compared to vaccine only, where the respiratory surfaces had less preparation to handle SARS-CoV-2, plus the preparation was for lesser time, and that was 5 months. So that is the basic study. It's fascinating. But please remember, it's a preprint. Let me very quickly show you who are the contributing departments. So here, Oxford Vaccine Group, Department of Pediatrics, University of Oxford. And similarly here, Institute of Immunity and Transplantation, UCL London, etc. So Liverpool. So good, reputed organizations and schools. So look at this. Department of Medicine, Division of Infectious Disease and Global Public Health, University of California, San Diego, La Jolla, USA. So This is the study. Let's look at the study. So, respiratory mucosal immunity induced by vaccination is vital for protection from coronavirus infection in animal models. So, they're talking about respiratory mucosa. So, if I can, and if you are just generally not happy about vaccines, or so, I would request you to mute that dialogue in your mind for a second and look at the um, mechanisms. Sorry, I'm drawing, so I stop talking when I'm drawing. So let's say this is the lungs and these are the airways. The epithelium, the surfaces are called the epithelium. And remember that we had this discussion even with that nasal vaccine from India, that the surfaces are wet. So in front of these cells, or these cells are covered by wet surfaces or a layer of fluids called mucus. So, what they're talking about is protection in these areas. And I think you can agree that if these areas, if the surfaces are protected, then getting infected and disease, infected is just the presence of a pathogen, and having disease, that disease is the symptoms of the problem, will actually be less. And they talked about it in their study. They said that when there was surface protection, then the viral infection got aborted before multiple viruses were made. That is, when the virus came in here and tried to enter a cell and start replicating, the immune system attacked it. And before it would make a lot of daughters, that whole process got aborted. This is a similar thing we saw with the nasal vaccines as well, because the virus has to have a foothold in the nose, and from there it would replicate and then spread. And that is also why povidone iodine like things are one of the tools for this. So now, please keep this in mind. Mucosal surfaces. So back here, respiratory mucosal immunity induced by vaccination is vital for protection from coronavirus infection in animal models. In humans, SARS-CoV-2 immunity has been studied extensively in blood. Remember, whenever you come up with a study, may that be by infection or vaccine or hybrid, usually we talk about antibody titers, antibody levels, waning of the antibodies, but that all is in the serum. However, the capacity of peripheral vaccination, over here, the peripheral vaccination simply means vaccination through, let's say, intramuscular route. It's away from the lungs, it's in periphery. However, the capacity of peripheral vaccination to generate sustained humoral and cellular immunity in the lung mucosa, and how this is influenced by prior SARS-CoV-2 infection, is unknown. So again, I want to make sure that we understand what their point is. Their point is, if you give an intramuscular vaccine and then you are expecting a protection of respiratory surface, that study that says that how well the surface is protected are not present or aren't a lot. So they went out and they said, all right, let's do this study. Bronchoalveolar lavage, samples obtained from vaccinated donors with or without prior infection, revealed enrichment of spike-specific antibodies. So they said, so I know bronchoalveolar lavage is a little more because I had worked in chest medicine as well as part of my residency. So we used to do balls all the time. So where we'll just have fluid go in the lungs, and then we would drain that fluid, and that will become the bronchoalveolar lavages. So bronchoalveolar lavage samples obtained from vaccinated donors with or without prior infection revealed enrichment of spike-specific antibodies. Right, so spike-specific enrichment means what? So let's say we have this spike over here. Right, so S1, S2, receptor binding domain, should we make it an angry looking spike? angry looking spike, right? All upset. So enrichment of antibody means that there are some antibodies that can bind here, there are some that can bind here. So there is a diversity in them, some that can bind here, and so on. So bronchoalveolar lavage samples obtained from vaccinated donors with or without prior infection revealed enrichment of specific spike-specific antibodies, class-switched memory B cells and T cells in the lung mucosa. And we have done this discussion as well of understanding what class switching is. So let's say this is this is a B cell. B cells, when they are naive, that means they're not triggered yet, they're not functional yet. They usually produce two kind of antibodies, IgD that stays stuck usually on their surface, and IgM. So I remember it as MDGA. This is a class switching sequence. M and D first, and then G and E and A. Imagine you have a doctor, her name is MDGA. So IgD and IgM are present. Then as this B cell becomes activated because of a T helper cell. Remember that there is T helper 2 cell that would release interleukin 4 and interleukin 5 in response to a antigen presentation to it, and that would cause the B cell to become an active B cell. The active B cell will become elongated because the cytoplasm will become filled with antibodies that it is going to secrete. I call it a pregnant cell. So it develops this little pregnant belly, and the nucleus is pushed on a side, and this is called a plasma cell. Plasma cells are releasing antibodies. Then what happens is, as these cells are doing their function, in this process, they are dividing as well. So there are going to be more daughter cells. And when they're dividing, they can do class switching, meaning they can move from one antibody type, for example, from D or M to G. So, for example, this daughter cell might start making IgG. Then there may be another, or from here there may be another that would start doing further class switching, and it would start making IgE. Then further differentiation and proliferation may cause the B cells to start making IgA. This is called class switching. Class switching occurs when a B cell continues to be exposed to the antigen and it keeps feeling that I need to proliferate, meaning become more in number. So every time it makes more babies, then some babies start doing G and E and A. And usually the role is that the IgGs will go and circulate in the blood. They would also go through placenta to the baby. And I remember that as IgG, the G looks like a pregnant belly. On the other hand, IgA, its job is to be on the surfaces, so it protects the surfaces, and IgA is also transmitted to baby through breast milk. IgE, as we all know, is going to go and prime on the mast cells and then become the notorious mast cell activations and allergens in some cases, not in everyone. So they are saying that class-switched memory B cells. Now what happens is, as the class switching is occurring, we'll make some memory cells of these that would be in the future be able to make IgGs. We'll make some class-switched IgA memory cells that in the future can make IgA quickly, and so on. So this would be called class-switched memory B cells. And T cells in lung mucosa compared to the periphery, and periphery here, once again, blood, in the setting of hybrid immunity. Whereas in the context of vaccination alone, local antiviral immunity was limited to antibody response. This is a beautiful sentence to focus on. What they're saying is, when there was vaccine and then infection or hybrid, then all of these class-switch B cells plus memory T cells were all present near this mucosa. They could actually draw these cells out just by washing the lung surfaces. So these cells, these memory cells were present, enriched cells, trained cells were present here. So imagine now the infection occurs again. You would really handle that infection better. On the other hand, if a patient was given intramuscular, so let's say this is the deltoid muscle, and the injection, the vaccine is given in the deltoid, then of course more IgG is formed and less IgA is formed. But not only that, the memory cells that would be here would not really be the class switched T cells and all that. These will be mostly class switched memory B cells. And that's what they're talking about here, that in the vaccination alone, local antiviral immunity was limited to antibody responses. I want to edit this and add only. That is, they're saying T cell, switched T cells were not here. Memory T cells were not here. The body's only response here was with antibodies. But if somebody had vaccine and had the infection, then their response was not just the antibodies, but their response was also cytotoxic T cells. Their response was also more helper T cells. A complete, coherent, orchestrated immune system amplification compared to just the memory B cell or antibody amplification. So then they say spike specific T cells, spike specific, those T cells that would attack a spike or bind to a spike specific T cells persisted in the lung mucosa, this surface, lung surface, for up to 5 months post vaccination, and multi-specific. So multi-specific is not just a spike, but RBD and the nucleocapsid and others. And of course, if we have the actual infection, then of course our T cells and B cells will be able to attack multiple parts of the virus. So that is what they're calling multi-specific T cells. So multi-specific T cells responses were detected at least up to 11 months post-infection. So here, spike-specific T cells persisted in the lung mucosa for up to 5 months post-vaccination, and multi-specific T cell responses were detected at least up to 11 months post-vaccination infection. This durable lung mucosal immunity against SARS-CoV-2 seen after hybrid exposure cannot be achieved by peripheral vaccination alone, supporting the need for vaccines targeting the airways. Right? So again, at the end of the day, they are from various vaccine departments and they're talking about vaccines. So what they're saying is intramuscular vaccines may not be the only answer. The best way to move forward should be to create mucosal immunity, and for that, other kind of vaccines that can be respiratory should be produced. So this is the basic gist of the paper. If you look at its PDF, in here they have actually gone in detail to discuss what kind of various cells, T helper cells, CD8 cells, their memory cells, and what kind of responses they saw. And if you see here, for example, let me show you. Some of the levels were very interesting. Hybrid immunity had produced levels 8 or 9 times more than vaccine only. So here, for example, if I just search for the word fold in here, so this is the SARS-CoV-2 vaccination elicited robust systemic IgG response. So that is the IgG present in the blood to both S and RBD proteins, with levels being more pronounced in the infected vaccinated group, 3.4-fold and 3.3-fold median increase. So if you are wondering that if there is vaccine plus infection, will now that just protect the respiratory mucosa and not have the antibodies in the circulation? And they are showing that the antibodies in the circulation, IgG, were 3.4-fold and 3.3-fold median increase for these two type of antibodies compared to vaccine only. So that is one very interesting number. Then look at this number. In the hybrid immunity group, compared to the naive vaccinated group, so this was high levels of anti-S and RBD IgGs were also detected in the bowel fluid of SARS-CoV-2 vaccinees. Importantly, anti-S, anti-spike, and anti-RBD IgG levels in the lungs were also significantly elevated in the hybrid immunity group compared to the naive vaccinated group. And what was the difference? So we're talking about anti-S and anti-RBD IgG, 8.2-fold to 9.4-fold increase for S and RBD. And why are they talking about IgG? Because mucosal surfaces primarily have IgA on them. However, here the memory B cells and T cells were sitting there. They were class switched IgG producing cells too that were 8 to 9-fold higher than vaccine only. So then they talk about IgA. Interestingly, they saw that IgA would wane more readily. Then these are the memory B cells and so on. So again, these are interesting data points. We can discuss them if you would like as a detail for this study. But the basic idea is that vaccine only, especially peripheral vaccine, cannot produce mucosal protection as well as if the mucosa is directly exposed to the antigen, in this case, infection. But what they said was, of course, you're not going to go and ask people to go get infected. You would say that they should be exposure to the mucosa for the antigen via respiratory vaccines. So this is a discussion. Let's leave the COVID stats. I want to give you every day. I want to start with let's do the COVID stats and then we do something else. So here are the quick looks at the COVID stats. Should we do them or leave them and do them tomorrow or do them with Paul? Let's see. What do you think? Okay, so chairman says now. Okay, why not get exposed in a controlled situation? Ambal, the only reason for me, so if you asked me, for example, to say, we think you should go get exposed, the only thing that I do not know is who will respond more severely. So if you say by controlled that this will be a properly dosed environment, then that is equal to a vaccine. So that's a respiratory kind of a vaccine, but again, not with the infection, but properly dosed and controlled. I definitely have energy, so let's do it. M. Gregory says, any significant? No, there was something interesting here. So let me explain what I wanted to share. If you see here, this is UK, and this is case fatality rate. So this is not the number of cases or number of fatalities, but rate. So here, case fatality rate, Feb 26, 23, 2021, 3.21%. So out of 100 people who are infected, and we're talking about symptomatic infections, the detected infections, proven infections, 3.21% people died in these spikes. Lately, if you look at the case fatality rate, that is once again 2.64. So you can see the spike here. Although UK has stopped reporting data for some days now, but anyways, here you can see that case fatality rate has gone up compared to, for example, January 18, 2022, 0.14%. Or let's say beginning of near the end of October, December 2022, you can see it slowly started going up. However, this is also important to keep in mind that as much as it is a higher ratio, the overall numbers are less. For example, if I say that there is 1,000 cases and 10 deaths, whatever that number is, and then if I say there are 100,000 cases and 20 deaths, so the numbers are different. So here, if you look at the numbers, the top chart is the cases and the lower chart are the fatalities. So if you see here in this right area, the number of cases are actually still low. And so case fatality is higher, but overall numbers are smaller. So that overall number, again, every single death is a death. It's a destruction of a family's structure. So it's not a small thing. The numbers are smaller. For example, cases are here. These are 7-day rolling average, limited testing. These are cases and deaths per million people. And if you see here, the case is 56 per million. And in the past, for example, January 2022, 2,674 cases per million. So compared to that, these cases are lesser. However, there is a spike in case fatality rate. With that, coronavirus, this is their Office of National Statistics, or Office for National Statistics. I wanted to show us the vaccination rate, or generally, I think it is important to see that a larger population set, I believe more than 80%, are vaccinated. That number was somewhere over here. Over 15 million people aged 15 years and over have received an autumn booster in England as of 30 January 2023. Over 9 in 10 people aged 12 years and over in the UK had received one dose of COVID-19 vaccine, so 90%. That is vaccination status. Then this is antibodies. This was more interesting for me. This was if you do serology and you look at the antibodies in people's blood, antibodies against SARS-CoV-2. The presence of antibodies against SARS-CoV-2 suggests that a person has previously been infected with COVID-19 or vaccinated. So in the week beginning 28 November 2022, the percentages of adults estimated to have antibodies at the 800. So they had two cutoff points here, 800 nanogram per milliliter and 179 nanogram per milliliter. I believe below 179 they considered as not effective, 800 they considered as robust, and above 179 they considered as having the presence of previous infection or vaccine. So here 80.6% in England, 79.7 in Wales, 78.3 in Northern Ireland, 79.6 in Scotland. So this was the serology. I think this is very interesting. And then if we go to the overview, so if you see here, they're saying infections continue to be decreased, hospital admissions increased, deaths decreased. So as much as the CFRs are changing, overall, the death rate is not death rate, deaths, absolute deaths are reducing. The hospital admission had actually increased. If you see here, this tiny uptick here, Paul would do a better job of discussing it. And then coronavirus latest insight infections. So 1.42%. So this is the estimated percentage of people living in private households, those not in care homes, testing positive. 1.42% in England, 1 in 70 people are testing positive, 1 in 80 in Wales, 1 in 65 in Northern Ireland, 1 in 70 in Scotland. An estimated 2 million people in private households in the UK, 3% of the population, were experiencing self-reported long COVID as of January 2023. That's a very high number, 2 million people. And this is again those who are reporting it. It's not necessary that everyone who has it is reporting it. So long COVID is a problem. So COVID-19 infections continue to decrease across all UK countries, and we looked at these numbers. And finally, deaths involving coronavirus. The number of UK deaths involving COVID-19 decreased to 881 in the latest week, that is ending 20 January, from 1,060 in the week before. Deaths involving COVID-19 accounted for 4.9% of all deaths in the UK in the latest week. This is a decrease from 5.3% in the previous week. In England, the number of deaths involving COVID-19 varied across age groups. In the week ending 20 January 2023, there was no deaths involving COVID among those aged 24 years and under. That's a very interesting and important data point. Deaths involving COVID-19 decreased in English regions except the East Midlands, where they increased, and the east of England, where they remained similar. So this is a quick look. And for me, these two were more important charts to understand that overall the numbers are not high, but CFR, case fatality rate, has become higher. So these are the discussions. Thank you very much for being here. Please like, subscribe, and share. And there are some links in the description if you would like to support this work, or if you want to become part of the patrons. We did a discussion of excess mortality with patrons and the Substack members. And the next topic, some of them were saying that, hey, let's do another deeper dive in the excess mortality. So the week after next, we might do that, or usual processes that patrons and the Substacks or the YouTube channels, Luffy Zooms, and democracy groups, they would figure out a topic or set of topics and they'll vote on it till this Friday. Then that is a topic that I would present. Also, please remember this Wednesday, I'm presenting with Dr. Paul Merrick about the diabetes and especially berberine. So don't miss that. I will be there on the FLCCC channel. Thank you very much, and I would see you tomorrow. Bye-bye for now.